Hi, welcome to MK Code Academy. Today I'm gonna talk about memory allocation. So to do this, we're gonna include stdlib.h, the library. Then, what is basically memory allocation means is requesting memory from heap. So to do this, we can use memory malloc, calloc, and realloc. How malloc works? So if you say int star p equal to, if we call malloc, it takes an argument. You can say any size, how many bytes you want. You can say any size, like if you say 6, like we want 6 bytes from the memory. Or if you want to, we can also say size of the type we want. If we want int, we can say int. If we want long, we can say long. If we want char, we can say char, anything. Let's say int. Then now this star p is carrying an address which has this size of bytes we requested from heap. So heap gave us these bytes. So if you want to access this p, if you say p equal to 5, any number, so any value, if you give p to any value, it's actually changing the address p to this. So it's not going to work like this, because the address in the memory. So we can say we have to dereference the p. If it's a star p equal to 5, it's gonna dereference the p and it will set the value equal to 5. So if we print f star d \n then star p, it's gonna give us 5. But if we just save p, it's gonna give us a random address. This is a pointer, so p is gonna give us a random address. So this how we can use malloc. So how, this is just integers. How about if we wanna, if you want something from like something like array from the heap, size of an array. So this array can be different, because suppose the array is a array of integer and it has 5 elements. So we can say 5 size of int, 5 multiply size of int. So what is this gonna do? Now we have to set, because this star p is carrying an address which has an array of int which is like 5 elements. So if we want to dereference it again, we can say star p gonna dereference it. Star p equal to 3 is going to dereference the first element of the array, like 0th index. So if we print f %d \n, and if we print star p, it's going to give us 3 right now. Then if we print star p plus 1, is going to give us the second element. If we set it to 4, it's going to give us this. Oh, we are printing a star p here, so you have to print star p plus 1. What is that? There's a parenthesis around this, so it's going to give us 4. We can also use this way. We can say p array 1 is going to give us, it's going to print the 4 again. So if you want to print the 0th index, you can say 0. If you want to print the 5th index, you can use 5th. For the 4th index, we can use 4. So if you say 4, it's going to print the 4th index. So that's how malloc works. Now calloc, what malloc returns is every byte is uninitialized, but the calloc int star PC equal to calloc initialize every byte to 0. So calloc, this is the only difference from between malloc and calloc. So calloc took two arguments, like how many elements you want. If you want only an integer, so you can say 1 comma like size of any integer, size of int. But if you want more elements, or it's a star, but if you want more elements from the more elements like an array, then we can say more elements like 5, 4, anything we want. This is gonna set every bytes to 0. So this is how calloc is different than malloc. And realloc, int star pr equal to realloc. Realloc also take two arguments. The pointer, old pointer, like we already set it star p equal to this, we can call p again, the old pointer, and the new size we want. This was an array of 5 elements of 5 elements of an array of 5 elements. We can set it to 6 elements if you want. So how much is the element gonna be? 6 multiply size of int. So we are requesting new memory from the existing memory. So we can use realloc this way. So in realloc is kind of tricky. If this p is already null, like if it is like q or anything, if this p is equal to null, right? Because this has a memory, but if this p equal to is a null, then it's just and we do this, it's just calling malloc because it's already null, where it's not changing anything. But if it is not null, it's going to change this address and it's going to increase some address from that. And this is not null, but we gave this is 0. What this basically going to do, it's just going to call free. Now let me show you what is free means. If we call free p, what is this going to do? We called this memory from the heap and we used it. Then if we call free, it's just gonna give the memory back to the heap. That's what basically free does. So this is what dynamic memory allocation is. Now I'm gonna tell you how to dereference something when it's a void pointer. Now it's an int, so we can easily dereference it. How about if it is a void pointer? So how I'm gonna dereference it? So we can dereference it by if we want to dereference it to integer, we can say star int star, and we're calling this pointer p equal to, if we put 5, so this p star p gonna give us 5. That's how it differentiates. But you cannot just say star p equal to 5 because it's a void pointer. It's gonna give you error. So that is all for today for memory allocation. If you guys have any question, just let me know in the comments below. I will answer your questions, and please don't forget to like and share and subscribe my channel. Thank you.